Alright, this video is going to focus on how to find z-score, convert it to area or probability using a chart and or calculator, as well as talk about the empirical rule and percentiles. So first thing we have to understand is that the z-score is simply a formula, and this is the formula from the SOL formula sheet for the state of Virginia. And that formula simply uses the given problem you're looking at, otherwise known as X, or the data element, and that's right there in the formula. Okay, it then will subtract off the average or the mean, which is called mu, and then from there you'll divide by the standard deviation. And that makes sense considering that the z-scores are simply a middle deviation, and so this shows you a way to convert between standard deviations. Once you do that, you can either use a chart or a calculator. And the calculator, as you can see, is just a few buttons. This is the TI-84, so you just go second, variables, and you go into the distribution menu, and we're only going to use choice 2. And then you put a lower and upper end, and it will convert it to a area or probability. To convert that to a percentage, you just move the decimal place over 2. To use a chart, you're going to do a similar thing. You're going to calculate your z-score. You're going to take the z-score and you're going to look at the table. So let's say I had 1.8. I would go to 1.8 on the left side of the chart, and then the 0 decimal place here, I would then scroll down from 0, find the combination of 1.8 and 0, and then that combination gives you the area, which is 0.9641. So here's an example of the chart. What I'm going to do simply to use this chart, let's say I wanted to find the area of 0.46. What I would do is I would first, find this value on this side of the chart, 0.4, and then the 6 would be the top, so 0.06, and it's in the second decimal place. And I would just scroll over from the left side until it intersects with the column, and so the area there would be 0.6772. And this chart is going to find area below. It's very important to understand that. This does not find area in the middle or above, just below. There's also a negative side of the chart which would find values below. Notice they are much smaller because you're below the mean. The mean is 50%. Alright, let's take a look at an actual problem. It really helps here when you do this to sketch a picture of what's happening. Okay, so what I'm going to do is I'm going to find the area and percentage below a z-score of 0.86. So what I do is I graph a normal curve, I put the standard deviations on, and I find 0.86, which is between 0 and 1, closer to 1, and this is asking me to find the area below. Please note that this makes a domain, and that domain is negative infinity to 0.86. That's important when we use the calculator, but first we'll use the chart. So I'm going to find 0.8 on the left, so I'm going to go to the positive chart, and we're going to find 0.8 here on the left, and then 6 as a column. So if I go to 0.8 and I scroll across to 6, right, and then I go down from there, I find that the value is 0.8051, or as a percentage, 80.51%. So let's take a look at that. As you can see, we have those two values here. So to use the calculator, what I'm going to do is I'm going to run a program in the calculator, and that program will find this value very quickly for me. So here's how that works. I get to my calculator and I hit second. Okay, so I'm going to hit second distribution. I'm going to go down to choice 2, and then once I'm in there, I don't use this. This is -1 to the 99th. What I'm trying to look at here is I'm trying to look at simply the domain. I'm trying to look at negative infinity to 0.086. So it'll suffice to just put in negative 1,000 here, negative 1,000. And then I put in 0.86, and then I run the program by simply hitting enter. It runs the program and finds the exact same amount that I saw on the chart. Alright, so what if I wanted to find something that was above a z-score? Okay, so what I do is I graph it. Again, it really helps to sketch a picture of this graph. And I go from negative 2.18 to infinity here. It's the whole thing. And you can see that's going to be a large number. So the trick for the chart is I got to understand that this negative simply means opposite. So if I go to the chart and find negative 2.18, it would give me this value, which I don't want. It's just a very small value. So to find this upper value, to find this value up here, what I'm going to do, instead of looking at negative 2.18 on the chart, I'm going to look at positive 2.18 on the chart. Why would I do that? Again, I want you to think about this. If this is below, by using the opposite value, it's going to find above. So if I go to 2.18, okay, what I'm going to do is I'm going to go 2.1 all the way over to 8, and then I'm going to go down from 8, and you can see that's 0.9854, or 98.54%. Okay, so if I go back to the problem, you can see that those are the values I wrote down. So how do I do it on the calculator? Well, again, it's about the domain. The domain is negative 2.18 to infinity. So if I go to my calculator and go back into second distribution choice 2, and I put that domain in, right, the lower part of the domain is negative 2.18. Since I'm going above this and going to infinity, again, 1,000 will suffice instead of infinity, since you cannot put infinity in the calculator. So I go ahead and paste that, and boom, you can see I got the exact same answer from the chart. So what happens if I want between two standard deviations, two z-scores or standard deviations, in this case z-scores? What I do is I take the first one, okay, which is negative 1.1, and the second one, and I actually have to find both of them and subtract, and you do it in this order. You take 0.6, which is the larger one, you find that value on the chart, you write it down, and then you find the one for negative 1.1, which is here, and you write that down, and you just have to think about this logically. To find that blue area in the middle, you take the area for 0.06, write it down, and subtract the area from negative 1.1, and you'll get the area in the middle. And this is where the calculator really shines, because to do the calculator here, you would simply go, right, you would just go second, distribution, you go to number 2, and then from there what you do is you put in the lower domain limit, negative 1.1, so negative 1.1, okay, you hit enter, and then you put in the upper domain limit, which is 0.6, okay, and then from there you will put in, just hit enter, and it will calculate the value. So the value is 0.5901 if you go to 2 decimal places. So there is no chart for between values. You either have to subtract or just type it in the calculator with the domain. So here's an interesting empirical rule question. So remembering from the normal notes that I had, if you had an empirical rule that went from negative 1 to 1, the empirical rule says that's 68%. But if I type the upper limit and lower limit in here, I get 68.269%. Now why does this happen? The empirical rule is an approximation. 68 is good enough for most, just quick calculations. And the standard normal probabilities chart will find more of an exact answer. Notice that that's in parentheses because statistics in general is all approximations. So you're really splitting hairs here. Do you want to be exact, quote unquote, or do you just want to do a good enough analysis? Alright, so what if I need to go the other way around? What if I need to take this number and get to the z-scores? There's another way to do that in the calculator and chart, and so the way we're going to do that in the calculator is we're going to hit second, variables, and then go to choice 3. In this class in Algebra 2, we only use 2 or 3. Never use 1 or anything else. Those are for more of an advanced statistics or AP statistics class. We're also, once we do that, we just type in the area and we do a left. We don't need to do center or right, because in this class we're worried about percentiles, and percentiles are defined as left values. So let's take a look at an example here. So let's say I come down here and I want to find a 50th percentile as a area. Now this is a question you can actually do in your head. The 50th percentile is the mean, right? That is the mu. So this answer should be z-score of 0. So if I look at the chart, if I go back to the chart and I look inside the decimals, right here is 0.50. And so what is the z-score? The z-score is just going to be, boom, right there. It's 0. Okay, the other example I had for the first one was what happens, how do I find the z-score, the area for a, how do you find the z-score with an area of 83.5 percentile? Now this is also on the the empirical rule. Now, how did I get that? The way I got this value was I got it from thinking about the standard deviations on the empirical rule. So remember that the mean is 50%, and then from there you have 13.5 to the first deviation. So that is how I got this number 83.5. So this one should be something that it comes out to 1, because 80 plus 13.5 is 83.5. But if I go to the chart, I'm not actually going to find this perfectly. So I'm going to be looking for 0.83 on the chart. So when I look at the values on the chart and I look in those decimals, the closest value I can get to 0.83 is actually right here. So I'm looking here and I get between these values. I'm looking 0.835. So the closest I can get is right in here. And you would go to the lower one. Okay, so from here what you would do is you would pick the lower one, and then you would go this way, which would be 0.97, and then you 0.9, and you go up this way, which would be 7. So the best we can do with the chart is 0.97. Again, it should be 1. Alright, so now that we have those two answers, let's take a look at how to do that on the calculator. So on the calculator, the way I would do this is I would get my calculator out, I would go to second distribution number 3 this time, meaning inverse normal, meaning taking area and getting a z-score. I put in 0.50 instead of 50 for the first one. And this is an interesting thing. You can't hit enter, you have to hit down and then paste. Okay, and then you'll find that it tells you it's 0, meaning z-score of 0. To find the next one, I do the same thing, second distribution number 3. Alright, and so I would go into the area and I would say, okay, that's 0.835 as an area. So from there, what I'm going to do is I'm going to make sure I don't make a typo there, and I'm going to hit enter, but then I can't go to paste, I have to hit down. So you might just want to hit down the whole time. And you can see there I get 0.9741. The chart only goes to 2 decimal places, so on the chart we got 0.97. So here's an example of one that is not going to be on an empirical rule. So in this example, what's happening in this example is that I have a 95th percentile. This is something like you would see on your SAT when you get it back. You know, you scored 95th percentile on the math. What does that mean as a z-score? Well, to do it in the calculator, you would simply go to second distribution, back to number 3, and then you just put in 0.95. So you can see this is pretty routine. In this course, you will always use the left one, never center or right, because percentile, again, by definition, is left. So you can see that that's a z-score of 1.64. And this makes sense because a z-score of 2, you know, if you add up all the empirical rules, is bigger than 95% of the curve, but it's, you know, it's pretty close. So to do the next one, the 35th percentile, same thing. We would go into our calculator, distribution, number 3, and then we would put in 0.35. And this number is going to be negative. Now I want you to think about this. Why would it be negative? Because 50% is 0 on the normal curve, and this is below 50%. So as you can see, this number comes out to a negative. So why don't we look at that one on the chart. Again, we're going to look for 0.35 on the chart. So if I go to the chart, I know that it's below the mean, so I'm going to look at the negative chart, and I'm going to be looking for 0.35. So I got to keep going down. So 0.35, I'm getting close, I'm getting close. The best I can do, right, the best I can do on this chart, if I look at it, is here, 0.3446. Because this one, the next one would be that one, and that's way not where I need. So that's the best I can do. The best I can do on the chart is to simply get this value with 0. So that one's only accurate to 1 decimal place, where if I used my calculator, again, I simply have way more decimal places that are accurate. I have, in this case, 0.4 negative 0.467. So the calculator in general is a better way to do it in terms of accuracy. If you need to, you can use the chart. You may run into a teacher that requires the chart, so that's one of the main reasons we go over it. Okay, I hope you liked this video. I hope it was instructive on how to use the calculator and the standard normal probability chart for z-scores, areas, probabilities, and the reverse of that.